Well, welcome back to our class on algorithms and data structures. We're continuing to make some good progress here as we're working through a lot of the details on these various data structures. And before we get into sorting, we're going to have another Java interlude that will help us to understand a little bit more about generics. And so let's just get into this. So this will include, continues our discussion on generics and interfaces that we began in Java Interlude 1. We will use these aspects of Java in the next two chapters, which introduces way to place objects into ascending or descending order. So for the interface comparable, the method compare to supplement 1 online describes the method compare to for the class string. This method returns an integer as a result of comparing two strings. For example, if S and T are strings, S compared to T is negative if S comes before T, 0 if S and T are equal, and positive if S comes after T. Other classes can have their own compare to methods that behaves in analogous fashion. All classes that define the method compare to implement the standard interface comparable, which is in the Java class library in the package Java lang. This interface, which is shown in listing J51, uses a generic type T to represent the class that implements the interface. Thus, by invoking compare to, you compare two objects of the class T, and we're showing that listing here. So let's create the class circle, giving it the methods equal and compare to, and the methods in the interface measurable, as given in listing P1 of the prelude. The class implementation, the class implements two interfaces, so we begin it as follows, and we're showing those details here. The name of the class appears in brackets after the interface name comparable. The circle corresponds to T in the interface and is therefore the data type of compare to parameter. The method compare to has the following implementation within the class as we're showing on the chart. This version of compare to compares circles by comparing their radii and assumes that the circle's its own equal method. While compare to need not invoke equals, these two methods usually should return consistent result. That is, if object 1 equals object 2 is true, then object 1 compared to object 2 should return 0. Note that the method compared to compares two objects and returns a signed integer that indicates the result of the comparison. And also note that enumerations have a compare to method. The order in which the enumerated objects appear in the enumeration determines the result of the compare. So here is generic methods, and suppose that you have a class that does not define a type parameter in its header, but you want to use a generic data type in a method of that class. For example, you might have a class of static methods that perform various utility functions. The class math in the Java class library is one such class. You would take the following steps in writing such a generic method. So you write a type parameter enclosed in angle brackets in the method's header just before its return type. You use the type parameter within the method as you would if you were in a generic class, that is, as either a return type, the data type of the method's parameters, or the data types of the variables within the body of the method. So in the listing shown here in the table, it provides an example of a generic method display array that displays the contents of an array whose entries have a generic type. The main method calls display array, passing in an array of strings and then an array of characters. So let's talk about bounded type parameters. In the previous listing, a generic data type represents any class type that the client chooses. Some situations, however, require that you limit or control the client's choices. For example, consider the following simple class of squares. Imagine that we want to write a static method that returns the smallest object in an array. The objects in that array might be strings, integer objects, or any objects that can be compared. That is, the class of these objects must implement the interface comparable. We need the client to give us an array of objects so that can be compared. Suppose that we wrote our method as follows, as we're listing here. Because the generic type T also represents any class type, the client could pass to the method an array of objects that do not have a comparative method. For this reason, the compiler will issue a syntax error. To correct this method, we must bound T so it represents class types that provide the method compared to. To do so, we replace the T in the method's header with a T extends compare T. Thus, the header becomes as we're showing here. What about wildcards? A question mark is used to represent an unknown class type and is referred to as a wildcard. To demonstrate its meaning, let's look at some statements in a client of the class order pair as given in listing J12 of the Java interlude 1. We call this method with the statement gadget small gadget equals my class dot array minimum my array. When my array is an array of gadget objects, because the extension T extends comparable T in the definition of array minimum bound, the generic data type T, gadget must implement the interface compare gadget. But insisting that a gadget object be compared only to another gadget object is more restrictive than we really need to be. What would happen if we had a derived gadget from widget where widget implements comparable widget, as seen in the figure here. If gadgets and widgets are similar enough to have the same basis for comparison, gadget would use a method compared to it inherits from widget without defining it, but then a call to the method array minimum with an array of gadgets and widgets as an argument would not compile. So it just gives you some more perspective here. Okay, that ends it for this short Java interlude. Thank you very much.